All right, now let's quickly answer the remaining questions on solid friction. Just a few more. I'm going to skip number 9. The question doesn't look clear. Maybe later when we are doing more frictions, I will add it. Now, question 10 says, when a box of 45 kg is given an initial speed of 5 meters per second, it slides down a horizontal floor a distance of 3 meters before coming to rest. What is the coefficient of kinetic friction between the box and the floor? This is a very simple question. What you have to realize is that when a box is, slide down on a floor, on a, rough floor, it is given an energy called kinetic energy. It immediately possesses kinetic energy because it is moving with velocity and it has mass. Kinetic energy is an energy possessed by a moving object. So for the frictional force to drag it down, the kinetic frictional force for the dynamic or kinetic friction to pull it down to rest, the friction must do a work which is equal to that kinetic energy of the body. So work done by kinetic friction is the kinetic friction times distance traveled by the body, or by the box in this case. So F times S will be equal to the kinetic energy of the box. So what that tells us is that the kinetic friction times distance traveled by the box is equal to half mass times velocity squared of the box. Mass of the box is 45 kg and its initial velocity is 5 meters per second. So half mv squared over what? Over 3 will give us the kinetic friction. So that means, you understand what I'm doing here? I've done all of this divided by 3. So all of this divided by 3. 5 squared gives 25. So that gives me what? The kinetic friction as 187.5 newtons. Now, to find the coefficient of kinetic friction, I'm going to say kinetic friction is equal to coefficient of kinetic friction times normal reaction. And that's what mu k, you understand? Mu k, coefficient of kinetic friction, is the dynamic friction or the dynamic friction divided by normal reaction. That gives me what? 187.5 divided by 45 times 10. And that's 5 over 12, or that's 5 over 12, or 0.417. That's how to find coefficient of kinetic friction. In question 11, two boxes 15 kg and 10 kg are connected around a smooth pulley on an inclined plane as shown in the diagram here. The question says we should find the acceleration of the system. This is very simple. 15 kg is heavy, 10 kg is lighter. So that means 15 kg will pull down 10 kg. So if you look at the diagram very well, the weight of this 15 kg will be acting downwards here. The weight of the 15 kg is acting downwards here. Since the system moves downwards on this side with an acceleration A, that means the weight, that means W overcomes what? That means the weight of the 15 kg mass overcomes the tension in the string. And the difference between the two of them is the net force acting on the mass. So W minus T is equal to MA. So in this case, I can rearrange. W is what? Mg. So Mg minus T is equal to MA. So if I take minus T to the right, it will become plus T. I can bring MA to the left, it will become minus MA. That gives me Mg minus MA is equal to T, or T is equal to Mg minus MA. Now, after concluding that T is Mg minus MA, I can just keep it like that without really simplifying, because sometimes they don't ask us to simplify. I can just keep it as T is Mg minus MA. And if we are asked to simplify, the mass is 15, acceleration due to gravity is 10. So 15 times 10 minus what? 15a is equal to what? T. So keep that as equation 1 somewhere, that expression. Now for the 10 kg mass, now for that 10 kg mass, there's a component of its weight acting along the plane. There's a component of its weight acting along the plane. Oh, I lost that. Excuse me. Okay, I think I'm here. There's a component of its weight acting along the plane. That's W sine theta or mg sine theta. Let me use this, mg sine theta. But since the system accelerates upwards in this direction, it means that the tension in this string overcomes mg sine theta. Both are dragging the mass. This one is pulling it downwards. The tension is pulling it upwards. But because the system moves in this direction, it means that the tension overcomes mg sine theta. Are you getting what I'm saying? This tension, it means it overcomes mg sine theta. That means the net force acting on the 10 kg mass will be tension, what? Tension in the string minus the component of its weight acting downwards along the plane, W sine theta. So T minus mg sine theta is equal to ma. So tension is what? Ma plus mg sine theta. So when I simplify, mg is what? 10 times 10. Then what? Ma is 10 times a. So 10a plus what? 100 sine theta will give me 10a plus 100 times 0.5. Theta is 30 degrees. That tells you that the tension is equal to 10a plus 50. Now look at this very well. We now have this as our equation 2. We have this as our equation 2, and we have this as our what? Equation 1. We have this as our equation 1. Tension is this, and what? Tension is also this. Tension is also this. So tension is 15. Tension is 150 minus 15a. Tension in the string is also 10a plus 50. So I can equate the two to each other. Are you getting what I'm saying, senior? Are you getting what I'm saying, senior? So I can equate 10a plus 50 to what? 150 minus 15a. That means if I bring minus 15a here, I get 10a plus 15a is 150 minus 50. So that gives me a is 100 over 25. And a is 4 meters per second square. But I think we were not asked to find a completely in meters per second square. Don't forget, I was supposed to, okay, a is supposed to be what? 4 meters per second square after using my g. But if I don't want it, I can say a is 4 over g. You understand? Because I've already used g. But if I divide by g, it will be 4 over what? Over 10. You understand? Meter per second square. That will give me, a is 4 meter per second square. Okay, if I didn't, okay, what I'm going to do here is that, let's assume I did not evaluate my g. I would have had what? 15g. This would have been 15g minus 15a. So let me use that. The first side is what? 15. The first side would have been 15g minus 15a. And the second side would have been, what is the g here? Okay, this would have been 10g sine theta. That's 10 times 0.5. That would have been 10a plus 5g here. So that would have been 10a plus what? 5g. So 10a plus 5g. So I would have had 15g minus 5g is 10a plus 15a. So 10g is equal to what? 25a. 25a is equal to 10g. So my A would have been 10g over 25, which is 2 over 5g meter per second square. So if we are not asked to evaluate g, or we are not given the value of g, that's how our answer will look. Question 12. This is similar. For the 4 kg mass, the weight of the 4 kg mass overcomes the tension in the string. But for the 2 kg mass, the tension in the string overcomes the weight of the 2 kg mass. Or the tension in the string, let's put it that way. The tension in the string overcomes the frictional force acting backwards on this rough surface. This is a rough surface. So let's take the 2 kg mass first. I think I made a mistake here. This is meant to be 2 kg. For the 2 kg mass, since the system moves in this direction, since the system accelerates in this direction, don't let that mix with the previous question. Since the system accelerates downwards in this direction, it means for the 2 kg mass, the net force acting on it is equal to tension minus friction. Tension is going to the right, friction is pulling it to the left, and the 2 kg mass is here. But since it ended up moving to the right, it means tension overcame the frictional force. So T minus Fr is equal to the net force, which is MA. Are you listening, senior? So that gives me what? Fr is mu R. Frictional force is mu R or mu W. W is mg. So it means tension minus what? We are given the coefficient of friction as 0.5. 0.5 times mass, 2 grams, times what? G. Will give me what? 1g. So T minus 1g is equal to 2a. T is equal to 2a plus 1g. So take that as equation 1. Let's now go to the 4 kg mass. Because the system moves downwards, it means the weight of the 4 kg mass, it means that this weight of the 4 kg mass overcame the tension in the string. So the net force acting on this 4 kg mass is W minus T, is the weight of the mass minus the tension pulling it upwards. So because it moved downward at the end of the day, it means this one beat or defeated tension. So let's go ahead and write our equation. So W minus tension is equal to net force. Net force gives it acceleration, ma. So the weight of the 4 kg mass is mg. So that means mg minus what? Ma is equal to T. I've rearranged. I took minus T to the right. It will become plus T. And I brought ma to the left. It will become minus ma. So that gives me what? Mg minus ma is T. So tension is mg plus ma from here. Can you see that? So tension will be 4g. The tension in the string is 4g minus 4a. Let's now equate this. Let's now take this as equation 2 and equate equation 2 to equation 1. We will get 4g minus 4a is equal to 2a plus 1g. So that gives me what? 4g minus 1g is 2a plus 4a. So 3g is 6a. A will be what? A will be 3g over 6. A is 3g over 6, or 0.5g. We are asked to take g as 9.8, so the system will move with an acceleration of 4.9 meters per second squared. Now question 13. Okay, there's nothing special about question 13. We've done many of these before. The pulling force is 500 newton. Normal reaction and weight are both 800 newtons. So if the object just moves, it means the pulling force is equal to what? Is equal to the frictional force. So F is mu R, and the coefficient of friction will be what? 500 over 800. The question says a box is pulled with a force 500 newton. If the mass of the box is 80 kilogram, it says calculate the coefficient of friction between the box and the rough surface. Calculate the coefficient of friction between the box and the what? Rough surface. So if the box just moves, it means the push just equaled the frictional force. And the frictional force is said to be what? And the push is said to be what? 500 newtons. So that means the frictional force too is 500 newtons. So using frictional force is mu r, and we know the weight, we know the mass of the box to be 80 kilogram. 80 times 10 will give you the weight, 800 newtons. So the weight will be equal to the normal reaction. So mu r is equal to what? 500. Mu will be 500 over r, and that gives you what? That gives you 0.625. So that's the end of the examples. You can take this as your exercise. For each of these one, find the acceleration of the system. For each of this one, find the acceleration of the system. I can put it outside here to be clear. So find the acceleration of the system in each case for each of these ones. For each of the questions in 1, 2, 3, and 4, just find the acceleration of the system. This coefficient of friction provided here is the coefficient of friction between this box and the rough surface on which it is lying. So instructions are the same as the previous one, and number 5 is like question 10 in the examples. So that ends our friction for this section.